Guys, today's video is on standard form and graphing of a quadratic. What we've been doing the last couple of weeks is taking these quadratic equations and solving for zeros. Now let's look at graphing them. We know that a standard form of quadratic is going to have the form ax squared plus bx plus c equals 0. But what we're going to do is we're going to set it equal to y, so it's going to be like y equals this, and we are going to graph our curve. The curve is a U-shaped called a parabola. And that parabola could be a smiley face or a frowny face. If the beginning number in front, so in this case, if the beginning number, the leading coefficient, it's called is 1, so if this is 1 or positive, then you get a smiley face. If the beginning is negative, the leading coefficient in front of the squared term, then you get a frowny face. Let's write that towards here. If A is positive, it opens up like a smile. If it's negative in front, it's going to open down like a frown. Any questions? Write them down. Let's get on to some more stuff. The axis of symmetry, important vocab word. Basically what it does is it takes your parabola and you are drawing a line down the middle to make it symmetrical. So it's a line that cuts the parabola in half. And it's always going to be a vertical line in our class. The important formula that you have to memorize: x equals negative b over 2a. Kind of looks similar to the quadratic formula. It's a piece of the quadratic formula. Actually, this piece and the discriminant formula from last week together make up the quadratic formula. It's kind of cool. So this is the axis of symmetry formula. We're going to use that to find the line that cuts parabolas in half. The vertex of a parabola, this is the next vocab word, is the highest or lowest point. For example, in the first parabola I drew, it's going to be the lowest point. In the other parabola, it's the highest point. It's where the parabola starts its turn, if you would say. So it's the lowest point. If it's the lowest point, it's called a minimum. If it's the highest point, it's called a maximum. Looking back to the two little sketches I drew, this would be a minimum since it's the lowest point of that parabola. This would be a maximum since it's the highest point of that parabola. Let's look at some more examples. First example, we have y equals x squared plus 8x plus 15. To find the axis of symmetry, the equation that cuts the parabola in half, we need the formula x equals negative b over 2a. Looking at this equation, a is 1, b is 8, c is 15. We don't even need c, but just in case. So plugging those numbers in, negative b, so we have negative 8. And if b was negative, it would switch to positive. 2a, so it's 2 times 1. So we get x to equal negative 8 divided by 2. Negative 8 divided by 2 is negative 4. And when you write your answer, leave it as x equals negative 4. That tells me it's a vertical line at negative 4 is what cuts the parabola in half. The vertex is the highest or lowest point. Looking at our sketch, I'm going to make a coordinate plane. Looking at our sketch, it's going to look like a smiley face, right? Because the beginning's positive. So the vertex would be at the bottom, it would be a minimum. But we want to find the exact coordinates of that vertex, and that's a little tougher to find. Here's the first step. The first coordinate of the vertex, because it's an x comma y coordinate, the first coordinate comes from the axis of symmetry. Whatever you found here is the beginning part of the vertex. So we're halfway done. To get the y coordinate, what you have to do is substitute the -4 in for your x's. So instead of x, I'm going to write parenthesis -4 squared plus 8 parenthesis -4 plus 15. Whatever we get here and we simplify will go in for that second part of the ordered pair. Here we get 16 minus 32 plus 15. -16 plus 15 is -1. So that is my y coordinate of my ordered pair. I can resketch this now because I know exactly where my minimum value is on the graph. It's at -4, -1. Here's the lowest point on my graph. And we know that it's a smiley face, again, because the beginning is positive. And there you go. Axis symmetry, vertex, and a quick sketch on how to graph parabolas. This little section of this video is actually graphing an exact version of your parabola. Before we just did a little sketch, now we're going to make the exact points. And to do that, you follow the steps by finding the axis symmetry, which helps you find the vertex, and then we can plot on our table. Let's do number 2. First, let's find the axis of symmetry. The axis of symmetry formula is x equals -b over 2a. In this equation, a is 1, b is 2, c is -1. Plugging those in into the axis symmetry formula, we get x to equal -2 over 2 times 1. So we get x to equal -2 over 2. -2 divided by 2 is -1. That is our axis of symmetry. Recall from the previous problem, our vertex is an ordered pair, where the axis of symmetry is the first coordinate. To get the second coordinate, you plug in -1 in for x, and in for the other x. So we end up with -1 squared, which is 1. 2 times -1 is -2, minus 1. That simplifies to -1 minus 1, which equals -2. Excuse me for trying to squeeze this in. So we get -2 as our second coordinate of the vertex. Now, let's start graphing. Take my vertex and put it as the middle ordered pair on my table. The other 2 ordered pairs on either side are just going to be random x values that I want to choose. I'm going to choose nice small numbers that are easy to work with. Let's work with 0 and maybe 1. Let's also work with -2 and -3. What we're going to do is once I got these numbers, I just got them from my head, just nice small numbers, you're going to substitute each number in for the x and come out with an output. So input, output. Let's do that. So what I did is I put in these numbers as my outputs. If I plugged in -3, I would get 2. If I plugged in -2, I would get -1. If I plugged in 0, I would get -1. And if I plugged in 1, I would get 2. Let's plot these on our graph. -3, 2 is here. -2, -1 is here. -1, -2 is here. 0, -1 is here. 1, 2 is here. And I'm going to connect these dots to make my parabola with arrows at the end. Get arrows because we know that the lines would go on forever in an equation. Write down what questions you have on finding the axis symmetry, finding a vertex, how to get these numbers in the table and also putting them on a graph. Have a great night, guys. See everyone next time.